In our next unit of study, we will be learning about complex numbers. And complex numbers include what we call the imaginary unit, which is a complex number whose square is -1. We represent the imaginary unit with the variable I. So since we know the imaginary unit has a square that is equal to -1, we know that I squared is equal to -1. So it follows that I will be equal to the square root of -1. Because if I squared was equal to -1 and I wanted to solve for I would have to square root both sides of this equation, which leaves me with the variable I, which is my imaginary unit, is equal to the square root of -1. Using this information, we are going to simplify numbers using that imaginary number I. So if you are asked to simplify the square root of -10, you need to recognize that the square root of -10 is equivalent to the square root of -1 times the square root of 10, because -1 and 10 was equal to -10. And you know, based on the definition above, that the square root of -1 is equivalent to the imaginary unit I. So this simplified expression would be I times the square root of 10. If I asked you to simplify the square root of -9, you would first recognize that the square root of -9 is equivalent to the square root of -1 times the square root of 9. In this case, we recognize that the square root of -1 again is I, and we recognize that the square root of 9 is equal to 3, because 9 is a perfect square, meaning 3 times 3 equals 9. This expression, I times 3, would be written as 3I. Now, if I asked you to simplify 5I squared, you would have to use your knowledge from the beginning of this lesson to state that I squared is equivalent to -1. So I could replace I squared with -1. And then I would multiply the 5 times the -1 to get an answer of -5. Complex numbers are going to consist of real parts and imaginary parts. When you write a complex number, you will write it in the form A plus BI, where A and B are real numbers. So, for example, the complex number 3 plus 4I has two parts. 3 is the real part, and 4I is the imaginary part. So when you write a complex number, that number has a real part and an imaginary part. You always write the real part followed by the imaginary part. We are going to learn how to add and subtract complex numbers. And to do this, we combine the real parts and we combine the imaginary parts. We state our final answer as a complex number in the correct form. So in our first example, we are combining 4 minus 8I and 2 plus 3I. And we are going to add these two expressions, which means you are going to add the real parts, which are 4 and 2. So we are adding 4 plus 2. And that is being added with the imaginary parts, -8I and 3I. We will combine our like terms. 4 plus 2 is 6, And negative 8i plus 3i is negative 5i. So we could write plus a negative 5i or minus 5i. So that was an example of adding two complex numbers. We can also subtract complex numbers. We will subtract the real parts and subtract the imaginary parts. So we want to subtract the real parts, 2 and negative 3. So we are taking 2 minus a negative 3. And we are also combining the imaginary parts, 12i, and we are subtracting minus a negative 7i. The minus and negative is going to become addition. So when we combine our like terms, we have 5 as our real part plus 19i as our imaginary part. Now, not only can we add and subtract complex numbers, but we are able to multiply complex numbers. Now, there are two different ways that we can look at this. We are going to look at problems which require we distribute, and we will look at problems that require that we FOIL. We're going to talk about that in a second. So, to distribute, the type of problem that you're looking at is when you have a single term, such as negative 4i, being multiplied by multiple terms, such as 7 minus 2i. So we need to distribute negative 4i to 7 and negative 2i. And distributing is multiplication. So I am multiplying negative 4i and 7 to get negative 28i. And I am multiplying negative 4i and negative 2i to get positive 8i squared. Now, to finish simplifying this expression, we need to recognize that I squared is equal to negative 1. So this expression becomes negative 28i plus 8 times negative 1. We substitute negative 1 for I squared. When I multiply 8 and negative 1, I have negative 28i minus 8. However, this can't be my final answer because we know to write our final answer as a complex number, the real part needs to be followed by the imaginary part. So your final answer here would be negative 8 minus 28i. Now, I said we'd come back to FOIL. On this next example, 3 plus 2i times 5 minus I, we are multiplying two binomials together because each of those expressions have two terms. The first expression has the terms 3 and 2i, and the second expression has the two terms 5 and negative 1i. So in order to multiply these two expressions together, we have to use what is called FOIL, which is simply saying you need to multiply each part of the first expression by each part of the second expression. So we will take the 3 and we are going to multiply it by the 5 and by the negative 1i. So when I perform that multiplication, I get 15 minus 3i. Now, we're not done with our multiplication because we now need to take the 2i, our second term, and also multiply it by the 5 and the negative 1i. When we multiply 2i and 5, we get positive 10i. And when I multiply 2i and negative 1i, I get negative 2i squared. Okay, there are two things that I'm going to do in my next step. I am going to combine the like terms, which are going to be negative 3i and 10i, and I am also going to replace I squared with negative 1. Okay, so when I do that, I get 15 plus 7i minus 2 times negative 1. And now we can perform this multiplication, and we have 15 plus 7i plus 2. For our final step, we need to combine our like terms again, our constants 15 and 2. And since we want to write our answer as a complex number, we need to write the real part first, 17, plus the imaginary part, 7i.